Okay, so hello everyone. In this video, we will cover three important methods for solving the critical section problem in operating system. So in this video, we will discuss lock variable, then test and set instructions, and then turn variable, which is strict alternation method. These concepts are fundamental for your competitive exam, university level exam, and interviews also. Now moving forward to lock variable method. What is lock variable first? Lock variable is one of the oldest method for solving the critical section problem. The fundamental concept is simple. Whatever process want to enter the critical section must first acquire the lock. When the work in the critical section is complete, the process release the lock. Now this method works in user mode, meaning we don't take any support from the kernel in the operating system. We implement it through API and application level code. Now how lock variable works? Let me show you a pseudocode and explain it case by case. So the entry section, while lock is equal to 1 and lock is equal to 1, critical section, and then exit section, lock is equal to 0. So this is the whole code. Now we have discussed before that we have to write entry section code and then critical section and then exit section code. Now initially the lock variable value is 0, indicating that the critical section is vacant. When the lock value is 1, it means the critical section is occupied by some process. Now what is the case 1? Case 1 is normal operation. Let's say we have two processes P1 and P2 and initially lock is 0. So when P1 arrives first, P1 execute the entry code while lock is equal to 1. Since lock equal to 0, the condition 0 equal to 1 is false. So P1 exits the while loop and executes lock equal to 1. So P1 enters the critical section. Now if P2 wants to enter, P2 executes while lock equal to 1. Since lock equal to 1, the condition 1 is equal to 1 is true. Now P2 gets stuck in the infinite loop and cannot enter the critical section. When P1 completes its works and exits the critical section, it executes lock equal to 0. Now P2 can check again. It will find lock equal to 0, set it to 1 and enter the critical section. This is the whole concept. In normal case, this seems to work fine, but there is a problem. What is the problem? The preemption problem. Means in case 2 we are seeing that what is the preemption problem. So here's where the lock variable method fails. Consider this scenario. P1 arrives and execute the first line of entry code while lock is equal to 1, and then since lock is equal to 0, the condition is false and P1 is about to execute lock is equal to 1, the second line. But just before executing this line, P1 gets preempted due to some interruption. But now P2 arrives. It sees the lock is equal to 0, execute while lock is equal to 1, then which is false, and then execute lock is equal to 1 and enters the critical section. Now when P1 returns from preemption, it doesn't restart from the beginning. It continues from where it left off and execute lock is equal to 1. So it will do what? It will overwrite the existing value. So it will make the value from 1 to again 1. So it will overwrite the value, then enters the critical section. Now both P1 and P2 are in the critical section simultaneously, violating mutual exclusion. We have discussed this in our previous video, that what is mutual exclusion. This is the fundamental flaw of the lock variable method. Now what is the summary of lock variable? It works in a user mode, it supports multiple processes, does not guarantee mutual exclusion due to a preemption problem between checking and setting the lock. Now what is the test and set instruction? This is another solution for this problem. Now the problem and solution is that the root problem with lock variable is that preemption can occur between the two separate instructions, checking the lock and setting the lock. Test and set instructions solve this by combining these operations into a single atomic instruction. Now how this will work? Like how test and set works? The pseudocode looks like this. The entry section, while test and set and ampersand lock, the critical section column, and then the exit section code is lock is equal to false. Now the test and set function is implemented in hardware as atomic operation. Now like what is the atomic operation for this? Boolean test and set, boolean target. What is this? This is pointer target. Now in this code we have written that boolean r equal to pointer target and pointer target is equal to true. Now return r in this function, this pointers. Now what is the execution example here? Initially lock is equal to false. When P1 arrives, P1 calls test and set ampersand lock. Inside the function r is equal to false, current value of lock, okay, and then lock is equal to true. The function returns false. So while false is false, so P1 exits the loop and enters a critical section. When P2 arrives while P1 is in the critical section, P2 calls test and set ampersand lock. Inside the function r is equal to true, current value of lock. Now then lock is equal to true, no change here. The function returns true, and then while is equal to true, P2 traps in the infinite loop. When P1 exits, it set lock is equal to false. Now when P2 calls test and set again, it will return false and P2 can enter. Now what are the advantages of test and set? Since test and set is an atomic hardware instruction, preemption cannot occur in the middle of the operation. This ensure what? This ensure mutual exclusion is guaranteed, progress is achieved. Like if a critical section is empty, any process can enter. The method is simple and works for multiple processes. Now what is turn variable? We will study one more thing here, one more solution here. Turn variable, a strict alternation method. Now what is the overview? Turn variable, also called the strict alternation method, is a software based solution that works specifically for two processes. It runs in user mode without requiring kernel support. The algorithm is what? Process P0 and process P1. For P0, while the condition is turn is equal not is equal to 0, and then critical section, and then turn equal to 1. Now what is P1's code? While turn is equal to 1 and critical section, then turn is equal to 0. This is the whole code. Now initially we set turn equal to 0, meaning P0 can go first, or turn is equal to 1, meaning P1 can go first. Let's say initially turn is equal to 0. When P0 want to enter, P0 checks while turn is not equal to 0. Then since turn is equal to 0, the condition 0 is not equal to 0 is false. P0 exits the loop and enters critical section. When P1 wants to enter while P0 is inside, P1 checks while turn is not equal to 1. Since turn is equal to 0, the condition 0 is not equal to 1 is true. P1 gets trapped in the loop and cannot enter. So when P0 exits, it sets turn is equal to 1. Now P1 can enter, and when P1 exits, it set turn equal to 0, allowing P0 to enter next time. Now analysis for turn variable. It provides mutual exclusion, guaranteed. If one process is inside, the other cannot enter because the turn variable is prevents it. So the mutual exclusion is achieved. Now is progress achieved? No, it is not satisfied. Even if the critical section is empty, a process might not be able to enter if it's not their turn. For example, if turn is equal to 0 but only P1 want to enter, P1 will blocked even though the critical section is free. Now bounded waiting is satisfied. No process waits infinitely. After one process finishes, it's automatically the other process turn. This is why it's called strict alternation. Now hardware independence, platform independent. This solution doesn't depend on any special hardware feature and can run on any platform. Now for conclusion, we have covered three fundamental approach for critical sections problem: lock variable, test and set, turn variable. Lock variable is what? Simple but flawed due to race condition during preemption. Test and set, hardware supported atomic operation that guarantees mutual exclusion. Now turn variable, software only solution for two processes with strict alternation. Now each method has its strengths and limitation. So that's it for this video. We will meet in next video. Until then, bye bye.